Welcome to the Black Doctors Talk podcast. I am Dr. Sharon H. Porter, host for this episode and member of the Black Doctoral Network. Today, I'm joined by Dr. Candice Ulmer, a clinical chemist at the Centers for Disease Control and Prevention in Atlanta, Georgia. Welcome, Dr. Ulmer.
Thank you so much for having me.
Absolutely. I would love for you to start out by telling our viewers and listeners a little about your background. Where does it all begin for you?
Sure, absolutely. So I was actually born to two educators in a rural part of South Carolina. Just thinking about that concept of rural in South Carolina is kind of funny because pretty much all of South Carolina to me is pretty rural. But I graduated from high school there as the salutatorian of my high school cohort, and I attended College of Charleston for undergrad. And so College of Charleston is pretty much an in-state school there, and I fell in love with that particular school and the city because of so many historic aspects. And at the time, I was interested in attending medical school, and there's a medical school that's not too far down the street from the College of Charleston. So they both have a very unique relationship that I was interested in kind of piggybacking on. So at the College of Charleston, I joined the McNair Scholars Program, and it was actually because of that program that I learned that my passion wasn't exactly in practicing medicine. Instead, it was in biomedical research. And so I basically did a career change and started pursuing a graduate degree. Immediately after finishing the College of Charleston, where I had a full ride there, I pursued my doctoral degree at the University of Florida. And so at the University of Florida, I was working with a world-renowned scientist in my particular field, and I was working as a Magna Doctoral fellow with a focus in analytical chemistry. And so I graduated there from the University of Florida in 2016, so pretty recent, at the age of 25. Basically secured a postdoctoral fellowship with the National Research Council at the age of 25 as well. And this was secured about a year before having finished my doctoral degree. And so then after having worked with my postdoc for a little bit, I was offered a position with the CDC as a clinical research chemist about 10 months before the end of my postdoc.
What an amazing background. Thank you. So I read that you've actually been practicing chemistry since you were 12 years old. How did this interest in math and science become so prominent at such an early age?
That's very true. So my mother, she was an English and a social studies teacher. She actually taught me in the 7th grade, but that's another story for another day. And so my mom was pretty adamant about my younger sister and me being prepared for the next grade. So she would actually purchase these self-paced instruction books that were always going to be a grade ahead of wherever my sister and I were going. And we were essentially required to kind of work through these books on the weekends and over the summer. And it's through working through these books that my mom really realized that I would fly through the math and science ones. And in everyday life, I was just always very intrigued about knowing why and how things worked. And so I become so advanced with these prep books that I actually taught myself algebra in the 5th grade. So my mom was really great about encouraging her own students as a teacher to make careers out of what it was that they were passionate about. And so she did the exact same thing with my sister and me, my sister being in art and me being in science. So she started enrolling me in STEM programs as early as the 7th grade at HBCUs such as Claflin University and Spelman over the summer so that I could really find my niche and perfect my craft when it came to science.
As an elementary principal, I absolutely love that connection, that you found that so early and then went on to pursue that. So kudos to mom.
Yes, absolutely. Kudos to mom.
Absolutely. So your doctoral research involves the use of mass spec for the early disease diagnosis of type 1 diabetes and melanoma skin cancer. What were major findings from this research?
That's correct. So my research definitely involves mass spectrometry, and we used it as a tool to basically identify biomarkers for individuals who could be considered at risk for the development of type 1 diabetes. So type 1 diabetes is considered an autoimmune disease, and basically what ends up happening is our T cells, which are supposed to be used to help us direct our immune systems and help us combat infections, they basically reprogram themselves and they start killing off the beta cells, which are used to produce insulin. So for a type 1 diabetic, it's very difficult for them to be able to break down glucose and use it for energy like our bodies can. So basically what I did is I performed an in vitro study using a cancer model. So basically I was in a laboratory working with a cell culture, and I wanted to simulate what it was like in a type 1 diabetic's body after having been introduced to a lot of sugar, a lot of glucose. So basically what I found out was using this systems biology approach, we call it metabolomics, where you basically just study small molecules like amino acids, lipids, etc., is that in a type 1 diabetic patient, their T cells reprogram themselves to something that looks like a cancer cell. We call it the Warburg effect. And so in these stressed environments, these T cells, when they reprogram themselves, the body uses something else for energy as opposed to glucose. They start breaking down another amino acid, glutamate. And so what was really interesting about that is we wanted to see in the cell culture model, what does it look like in an actual patient? So we recruited type 1 diabetic patients. We recruited their first degree relatives, so like a mother and a father, and basically wanted to see what it was that we were getting in the cell culture. Was it actually similar in a type 1 diabetic patient? And it was very similar. We saw that a lot of their metabolite and lipid signatures were pretty comparable to that cell culture model. What was really interesting is that these first degree relatives, so the mother, the father that did not have type 1 diabetes, their metabolic profiles looked exactly the same as a normal patient. But with that type 1 diabetic, you definitely did see a difference between the two. In regards to melanoma skin cancer, that was another project that I was working on while at the University of Florida during my doctoral degree. The reason why we started working on this project is we had a physician from Shands, the medical school and University of Florida, come to us and basically say that, cancer detection has been going on since 1989, specifically for melanoma. And if animals and devices can be used to quote unquote smell cancer, why can't you guys as chemists come up with some type of technique to be able to detect melanoma skin cancer on someone's skin? Because right now, if someone were to have melanoma skin cancer, the current screening and treatment profile is to either remove the lesion or what they call watch and wait. So it's the ABCDs, E's, where you basically look at the asymmetry of the cancer, you look at the border irregularity, the color, and the diameter of it. So what we basically did at University of Florida is patented a technique to basically be able to differentiate melanoma on the skin compared to a normal area. So what we did is we designed this probe that basically samples normal skin tissue and the cancer tissue.
And this really makes it more prominent to the research. It makes you realize how important the research is. We often think of the actual practitioner and the medical piece of it, but the research, wow. Thank you for that. Thank you.
Absolutely.
So as a woman and a minority in the STEM field, you undoubtedly have faced obstacles and barriers throughout your tenure. What were some of those challenges and how did you overcome them?
So in a field that's predominantly white and male, as an African-American female, you definitely stand out, and you stand out in a good way and you stand out in a less optimal manner as well. So for example, some of the challenges that I have to deal with, sometimes my suggestions or recommendations during brainstorming meetings at times have either been undermined or maybe even simply ignored for one of my counterparts to say essentially the same thing, but just different verbiage and be commended for their efforts. So it's a little frustrating. And it's also frustrating too in my field to at times always be asked to fill in for the diversity and inclusion role on boards instead of being invited to some of these same boards for your merit and your accomplishments. So ways that I've learned to kind of overcome them and to cope is to just essentially remember my purpose, to remember why I'm there, to remember that I'm just as qualified or more qualified than some of my counterparts. I've certainly had to develop tough skin. During my tenure in chemistry as early as undergrad, unfortunately, I've been called out of my name or being recognized as a pretty little Black girl in a scientific setting, which is very inappropriate. So I've learned to be vocal and to stand up for myself, to seek help and resources when I need them. And sometimes when I'm unable to communicate my thoughts, maybe because I'm frustrated or angry, to use written words that others have published as a means to be able to communicate my thoughts. And so most recently, me along with a couple of my other colleagues, we created this organization called the Coalition for Black Mass Spectrometrists. And this is basically a platform for Black mass spectrometrists to engage in discussion, cultivate a sense of community, and support each other. And so we basically started creating initiatives to call awareness to the need for policies to ensure cultural diversity and the representation of Blacks in STEM.
I really love that you saw a need and filled that gap with the coalition. And I'm certain that that has helped so many so far. So, and I'm sure it will continue to help. So thank you. So who are some of your mentors, and are you committed to mentoring others?
So one of my mentors is Dr. Wendy Corey. She's at the College of Charleston as an associate professor and an analytical chemist. She's been one of my mentors since day one. She took a chance on me and she allowed me to start conducting research in her laboratory as early as like after my sophomore year in undergrad. She was the one who actually introduced me to mass spectrometry. She trained me on the technique. And it's interesting because it's the same technique that I use even today in work. She actually even encouraged me to pursue a PhD at the University of Florida, which is her actual alma mater. And so once I had actually settled on the school, she helped me find an apartment in Gainesville, Florida, and even gave me suggestions of who to work with during my doctoral program. So her influence on my life has been absolutely, necessary, and I'm so appreciative of her mentorship. And so as a result, I'm committed to mentoring as well, because I think it's so important to give back. Mentorship to me is a mutually beneficial relationship. And so the mentor and the mentee, you learn so much from each other. And so now as a mentor at work and through a couple other organizations, I've created opportunities for some of my staff even to gain experience presenting our award-winning research and published manuscripts, which is a first for many of them.
I love that. And, as an elementary, middle school principal, I really think that the mentoring piece is so important, even as early as elementary, to get our young ladies interested, first of all, and aware and exposed to STEM fields. So, how early would you suggest, just as a follow-up to that mentoring question, that individuals that are in the field reach back and reach maybe a younger, maybe not high school or college, but even middle school and elementary school?
Yeah, I don't think there is any age limit. I think as soon as a child shows that they're interested in discovery, innovation, knowing why, that we should start cultivating that thought and that yield for wanting to know more. So I even do that now with my goddaughter. If she's interested in, something as trivial as Play-Doh, we talk about what is Play-Doh, how do you make Play-Doh, where do the colors come from, and just kind of stimulate that thought process for asking the questions why, how, and how come.
I love that. I love it. You were involved with the first interlaboratory lipidomics comparison exercise. Please share a little information about this study.
Sure. So before I kind of go into that study, I'll quickly talk about what is lipidomics and why does it even matter. So lipidomics is basically the analysis of lipids in response to some type of perturbation. So that could be a disease, it could be an environmental exposure, etc. And so basically what you're doing is you're looking at how the lipid profile changes in response to like maybe a disease state. And so the lipidomics field is what we consider an emerging field. It only really started in the early 2000s. So as a result, there are fewer guidelines and workflows for the way that samples should be collected, samples should be stored, the way that you analyze them, as well as once you have the data, what do you do with the data? How do you report out the information, et cetera? And so a substantial roadblock that we've seen in the progression of adapting lipidomics into the clinical field is the lack of standardization and harmonization within the lipidomics community. And I mean that domestically here in the US as well as internationally. So our lipidomics study was actually spearheaded by my postdoctoral advisor at the National Institute for Standards and Technology, NIST, in Charleston, South Carolina. His name is John Bowden. And the study was basically designed to highlight some of the challenges and why the data looks so different from one lab to the other lab when we're analyzing the same sample and reporting the same lipids. We also wanted to kind of look at what was the uncertainty involved in each one of these lipid measurements to basically see how we can contribute to eliminating some of that variance. And in the midst of that, we also wanted to create some software packages, right, to help standardize some of the lipid measurements. So the way that we went about doing it is we sent out 3 different types of samples. These were standard reference materials to laboratories both domestically as well as internationally. So we had 18 laboratories that we sent these samples to in the US and 14 that we sent to other countries. And they represented every sphere of research. So we had individuals in academia, industry, as well as in government laboratories. We asked them to literally run the samples as you normally would in your lipidomics lab and report back the measurements. And so as we expected, because everybody's doing something different, the data made absolutely no sense. So a lot of my work during my postdoc was to try to make sense of nonsense, to basically see what were the contributing factors to why the results were so different if we were given the exact same samples and asked to report on the exact same lipids. And so through the data as well as our analysis, we were able to create 2 software, which I was heavily involved in writing and designing, and we called them Lipid PC and Lipid Pioneer. And they were basically written to address some of those issues we saw in quality assurance and accuracy with lipid measurements.
Thank you. Now, you are currently working at the Center for Disease Control and Prevention, CDC, as a clinical chemist, where your focus is providing the accurate measurement of chronic disease biomarkers. Please share the connection of biomarkers such as parathyroid hormone to patients' treatment of chronic kidney disease, mineral bone disorder.
Sure. So with the rising incidence of renal failure that we see here in the US, chronic kidney disease has become one of the leading health conditions in the US. And so what's interesting about chronic kidney disease is that the earlier stages of the disease generate fewer symptoms. And unfortunately, it's not until the kidney has become significantly impaired that patients actually start experiencing some of the signs and symptoms of renal failure. So parathyroid hormone is just a biomarker that they use in the patient diagnosis and treatment of CKD and PD, so chronic kidney disease, mineral bone disorder, as well as a couple other disorders as well, such as hypoparathyroidism and hyperparathyroidism. The reason why we study this particular biomarker is because we've noticed clinically that elevated levels of parathyroid hormone have been associated with some of those higher stages of chronic kidney disease. And so there have been a couple of different clinical guidelines that have basically emphasized the role of parathyroid hormone as one of the key biomarkers for this particular disease. So this is the reason why it's at the CDC and why we are kind of developing a reference measurement procedure to measure it. Anti-PTH, so parathyroid hormone, when our body excretes this or secretes it into the blood, it's basically secreted at very, very low levels. And it breaks down on the order of minutes to hours in our bodies. And so we start producing some fragmented versions of the parathyroid hormone. The reason why this is important is because right now, clinically, the way that parathyroid hormone is measured is using some of these immunoassay platforms, like a clinical analyzer. So whenever you get a blood draw, it's taken to a clinical lab, and they basically give you a printout of some of your levels in your body. And a lot of times those measurements are given using a clinical analyzer. Well, this clinical analyzer has a very difficult, experiences some difficulty in measuring parathyroid hormone because it also picks up those fragments that the body produces as well. So our numbers for parathyroid hormone are not as accurate as we want them to be. So at the CDC, what I've been tasked with is developing a more accurate approach to measuring parathyroid hormone so that we can begin to standardize our levels that we're getting with this reference measurement procedure to some of those clinical analyzers. Because this variability that we're seeing, unfortunately, could lead to the misclassification and the inaccurate diagnosis of patients. And we certainly don't want that.
It's really fascinating. And my father actually suffered from chronic kidney disease. He passed in 2008. So I always, especially right after that, was very interested in learning more, were the signs. And it was interesting that you said that the earlier part is when the signs really aren't there. What can one do, who perhaps they are suffering or their loved ones are suffering from this? What are some steps that they can take?
So I am a strong advocate for early disease diagnosis, and the only way that you can go about doing that is by establishing your own baseline. So what that means is, annually or every 6 months, going and getting a blood draw and essentially looking at what your numbers are. And I mean a full metabolic profile. And basically sticking with the same doctor, because we know, unfortunately, that every physician or every hospital may have a different means of getting these numbers. They may have a different type of instrumentation that they're using. So staying with the same doctor, staying with the same hospital allows for you to get your own baseline and to see how your profiles change over time. By seeing a blip or a change, something that, elevated substantially or dropped dramatically, may give you some insight into whatever this disease may be, whether it be cancer, whether it may be renal failure, etc. So getting ahead of the curve, being on the offense as opposed to the defense.
Great advice. Thank you. So, Dr. Ulmer, what keeps you going? What motivates you in this fascinating research?
So I think that I am always drawn to innovation and finding the unknown. I love doing research in the biomedical field because I can directly see the impact of the work that I do every day here in the US as well as internationally. And so I'm always looking for strategies to solve questions a different way.
Love it. So, just really keeping with that because in order to go through this, and like you said, solving problems in multiple ways, that has to keep you up at night a lot of time because you are just so ingrained and so engrossed with finding, different solutions. How do you handle all of that?
That's a great question. The first thing that I do for sure is I have an outlet. And so my outlet for me is running. I enjoy doing long distance running. I enjoy meditating. And so having that clear separation between work and having that healthy work-life balance, I think is crucial for someone in my field where the work never really turns off. They say the CDC is 24/7, and at times it feels that way. So it's important to kind of have that balance between when you need to turn things off and when you need to focus on self and family. So having that outlet is important, as well as being true to, my religious doctrine, as well as making sure that my support network stays intact. And so for me, my support network is my family and my friends.
Yes, that work-life balance is so important. Stay grounded, definitely. So from your experience, what are the best ways to recruit women and minorities to the STEM field?
That's a great question. And it's not, unfortunately, one straightforward answer. I think it's a lot of different things that culminate together to kind of help recruit women and minorities. So the first thing I think is we need to kind of tackle this issue from the top and then work our way down. So what I mean by that is we need to have more representation of women and minorities in high profile and leadership positions. We need to establish these mentorship programs so that we can have opportunities to recruit women and minorities in, but to also ensure their retention in that particular job and in the field. We need to have ways to evaluate the effectiveness of these programs that they have, in different institutions, and begin to start collecting the demographic data to show the need for inclusivity and the data for how these initiatives and programs and policies are or are not working. And so then from there, I think another way to ensure that women are recruited and that minorities are present in STEM fields is to have an equal divide of the work, in projects and in different opportunities that are presented within our fields. So I think the approach of working from the top and working our way down is how we need to really eliminate this issue that we see and the lack of representation for women and minorities in STEM.
Exactly. A mindset shift, I feel needs to occur as well. I was looking at a social media post, and someone was in a department store, and there were NASA shirts, and they were all in the boys section, and none were in the girls section. And it was just a topic. And I think it's things like this, that come up in society still, puts us in a box that, we're not able to do things. So I think all of those suggestions are so important, with the top down starting first.
Absolutely.
And so,
there
yes.
was a podcast, not a podcast, but a documentary that they showed not too long ago, Picture of Scientists, that got featured by a couple different scientific organizations. And it just kind of speaks volumes to us not really understanding, what it's like to be a woman and what it's like to be a minority in STEM. And because there's a lack of understanding, there's a lack of initiatives at the top to ensure not only our recruitment, but our retention. Don't just recruit us and get us in there, but support us and nurture us while we're there, make us feel included throughout that entire process. I think it's very lacking at this point. There's certainly been some progress, but we still have a long ways to go.
And I would totally agree with that. I'm looking at it from the lens of early learners, being an elementary principal and wanting to expose my young ladies with everything there is to offer, and not limiting, what they can do in life. And so it really is just exciting to see you, as a face of STEM. And I'm sure that carries a heavy burden at times. But in order for them to see themselves, it's necessary. And so I just want you to talk a little bit about those individuals, such as yourself, in these positions, carrying that load on minorities, on women. What is the message to others in your same space that they can too add to this recruitment and retention?
Absolutely. So like you said, at times it does feel very taxing, and it is a large burden, but it's so important to have representation. And I'll give you my own personal experience of how representation was critical to me. As I was finishing my doctoral degree at the University of Florida, I was looking to find the next step. And so the next step for me was a postdoctoral fellowship. I wanted to gain a little bit more experience doing research. And so I was applying to a couple different labs. And I was recruited by NIST, the National Institute for Standards and Technology, for a particular lab in Charleston, South Carolina. It was appealing to me because I was going back home, South Carolina. But I knew that, unfortunately, the racial tension and the climate in Charleston, South Carolina wasn't great as an undergrad, and I knew it hadn't improved in 4 years. So I decided to still take the interview. I went down to the laboratory, and I was hoping and praying for some type of change, because if I didn't see any type of change there, I wasn't going to accept that fellowship. So as I was interviewing, I saw nothing but an all-white staff, even down to the janitorial staff, all white. And I'm sitting here thinking, for the next 2 years, I'm going to have to integrate myself into this culture. It wasn't until I got to my 4th interview for that day that I actually sat down with another African-American female, and I was floored. I was absolutely floored. And in my interview with her, I'll never forget, one of my first questions, before she even got a chance to ask me a question, was, how long are you planning on being here? Because you can't just be here and leave me here by myself. So she told me that she still had another year to go in her postdoc, and that she was planning on accepting a position full-time with NIST. And so I basically told her, well, as long as you're here, I'm going to be here. And so I accepted the position. We became very, very close, because it was pretty much just us against everyone else. There were instances where racially inappropriate comments were made, and we were kind of able to kind of stick together and work through situations like that. There were situations where I was undermined scientifically and intellectually, that she was there to support me through. And so it's actually critical to have that representation in the workplace. When she sat down and told me that she was actually going to be leaving the satellite location of NIST where we were and moving to Gaithersburg, Maryland under NIST, within a matter of a month after she left, I left. And it's unfortunate that even to this day, 2020 of October, there are still no African-American women at that particular satellite location. And so that just kind of speaks volumes to how we need to make it, so important and such a strong initiative to recruit more and to retain more African-American women in STEM. And just like how she was a supportive factor to me, we have to do that with other minorities and other women in STEM as well, to be that ounce of support, to be another backbone for them during some of those challenging and difficult times.
Just really amazing. Wow. So how has your affiliation of the Black Doctoral Network enhanced you professionally?
So it was actually at a Black Doctoral Network conference that I was able to kind of present some really new and novel research that I was working on during my doctoral work at the University of Florida. It's ironic because that particular meeting was held in Atlanta, Georgia, where I currently am now. So it was at that meeting where I was able to present some of my research to peers in a more welcoming scientific community, get feedback on what was working, what wasn't working, and to then begin to ask myself questions about how I can improve this in preparation for my dissertation and my dissertation defense. Also in 2018, the Black Doctoral Network gave me a member spotlight, and that was great because it really increased the visibility of me and my work. And it was something that I could share with collaborators and other individuals who were, looking to add me to particular boards and scientific committees, and just kind of a nice write-up of essentially everything that I had done in my scientific career up to that point.
Thank you. And I want to go back to something you mentioned earlier about being born to two educators. And I love that. And that undoubtedly really probably put you on the track to, where you are, And I just want to talk about the importance of that early home support. And really whatever field that you're going to, but specifically we're talking STEM. Can you talk a little bit about how that home support with mom and dad, both educators, really making sure that everything was in place to really set you up for success? How important is that home support?
It was absolutely critical. I don't think that I would have excelled in such a rigorous program and in such a rigorous and just intellectually demanding field had I not had that early start that my mom and my dad gave me at home. It was an understanding, like I mentioned before, that you were preparing for the next grade. She made it known to us that it was your teacher's job to reinforce. It wasn't their job to show you material for the first time. So whenever we got assignments from class, it was an expectation that you already started kind of going over the material and preparing, so that when you were in class the next day, you were asking follow-up questions, not seeing the material for the first time. So that mindset just created the foundation for us being able to learn, my sister and I being able to learn very early on, what type of learners we were, how best we studied. I learned that I was a kinesthetic learner. I needed to write notes. I needed to rehearse those notes. I needed to see the text, etc. And so when I was tasked, in undergrad with having to read 50, 60 odd pages of scientific literature, it wasn't overwhelming because I knew how to go about and, break that information down so that it was a little bit more obtainable and understandable. So I think us learning a lot about the way that we study, the way that we think, what we like, what we don't like, was something that would have taken us a really, really long time to have figured out after the fact, had we not had the support from our parents very early on.
Wow, thank you so much. You have accomplished so much. What is next for Dr. Candice Ulmer?
So I'm always always looking ahead. Sometimes it drives my friends crazy because I'll go through these little moments where I'm like, oh my God, I'm not doing enough. You're like, you're doing way too much. So for me, ideally, I'm working towards becoming a laboratory chief at the Centers for Disease Control and Prevention. And I'm also working to become board certified in the field of clinical chemistry. So I'm in the process now of kind of studying for those boards and preparing myself to become a director of a laboratory in the future.
So the board certification will allow you to do that?
There are ways to go about obtaining the director position without the board certification. But as I've kind of implied before, being an African American woman in STEM, a lot of times your intellectual capacity is undermined or you may be overlooked. And so something that I picked up from my mom is that you never give them an opportunity to miss your name. And so with this board certification, it pretty much propels me above some of my counterparts who may or may not be rooting for that same position.
Thank you so much. How does your work, your research, how do you all work in tandem with the medical doctors? Is there a direct link here, or what's that process?
Absolutely. So we work hand in hand with some of my doctoral work, as well as some of my work in my postdoc. We would actually collaborate with physicians. They would help us design studies so that we could recruit certain patients for a specific profile. So in particular, we were working with a project dealing with lupus, which disproportionately affects African American women, especially in the Gullah Geechee population in Charleston, South Carolina. And so we were working with the Medical University of South Carolina to recruit patients that fit that particular profile that we needed, that were lupus patients. They would collect the samples that we needed, whether it be plasma from a blood draw, even down to urine. And we would then take that to our laboratories and analyze those samples. So basically look at profiles and determine what could be potentially a biomarker to help some of these patients in the future. And so even now at the CDC, with a lot of the reference measurement procedures and clinical measurements that we get, they're used to establish some of these guidelines, these clinical guidelines that physicians use in everyday practice to determine whether someone fits a normal criteria or if they're moving towards any particular disease criteria. So it's a direct correlation with our work and disease diagnosis and treatment.
Thank you. Well, Dr. Ulmer, thank you for joining us today. It has been a complete pleasure. Please tell our viewers and our listeners where they can go to learn more about you and the work that you're doing.
Thank you so much for having me. The best way to reach me and to look at anything that I'm doing is through my LinkedIn profile. On there, it's Dr. Candice Ulmer, as well as information on Google. You can just search my name, and a lot of my research and things that I'm doing will definitely pop up. I'm present on ResearchGate as well as on Google Scholar. So any of my publications from the past couple years are present on both of those.
Thank you. Please be sure to stay connected to the Black Doctoral Network and connect with us on all of our social media platforms. Thank you for joining today for the Black Doctors Talk podcast. I am Dr. Sharon H. Porter, and we hope you will join us again next time. But for now, be sure to like, share, subscribe, and tell a friend.